What's going on, simplifiers? Welcome back to Dennis Simplifies. In today's video, we are going to go through the Adams-Bashforth method for the ordinary differential equations multiple steps. Alright, friends, so sit back, relax, and let's simplify. So we are familiar with this question that solve the following IVP with the equation y prime equals x with the values of the interval of x starting from 0 to 1 and the initial value of y being 1 with a step length which is equal to 0.2 using the Adams-Bashforth method for the third order. Compute all previous values of y using the Runge-Kutta of fourth order. Alright, so what we're going to be doing is that, so let's use the values we've been given from the question. We know that the h value, which is the step length, is 0.2, and then the interval of h starts from 0 to 1. Alright, so we can draw out our table as you know already. So we have h being equal to 0.2. Now the x values are starting from 0 and is ending at 1. So we know our step length for 0.2, we have 0.2, 0.4, 0.6, 0.8, and then 1. Alright, and then we know that our initial value for y is equal to 1. Alright, so friends, with the Adams-Bashforth method or the scheme for the third order, this is how the formula looks like. So this is going to be the formula for the Adams-Bashforth method or the scheme. So this is the formula that we have. Now from this formula, the whole idea about the Adams-Bashforth method is that we know that we are supposed to use for the Runge-Kutta method also. So we know that if you can see from this table here, the iterations are going to be a lot. If you are starting from y1, y2, y3, y4, they are going to be a lot. So with this multiple step, what you do is that you use an initial value from somewhere and then you continue. So what this Adams-Bashforth is saying is that Runge-Kutta already has the values for y0, y1, and then y2, right? So why should I even do it again, right? Why reinvent the wheel? So Runge-Kutta, give me your values and then let me continue. So if you remember our Runge-Kutta, this is the values that we had from our previous video. So you can go back to my previous video on Runge-Kutta and then you know that we had this as our values for the Runge-Kutta method. So we had the y not to be 1, 1.02, 1.079, and then 1.168. So you can see that the Runge-Kutta has these values already. So Adams-Bashforth is saying that Runge-Kutta, alright, so give me your first three values. That is y0, y1, and then y2. And then I am going to continue from there. So you can see that the Adams-Bashforth has 6 places. 1, 2, 3, 4, 5, 6. Right? Up to y5. So that's 6 places. So if I take the first three from Runge-Kutta, then I'm going to do the rest. So I'm taking the first three from Runge-Kutta and I'm going to do the remaining three. Alright. So Adams-Bashforth is going to take the three from Runge-Kutta, that is y0, y1, and y2. So as you can see here, so the Adams-Bashforth third order is taking it from here. So 1.02 and then 1.079. So it has taken the values from the Runge-Kutta. Now the next thing to do is that it wants to continue from there. So you can see that for the Runge-Kutta, the x values was from 0 to 0.6. So the Adams-Bashforth has increased the length, the step length to 1. That's from 0.8 and then 1 has added 2 more to it. So it's going to do for these remaining values here, right? So if you go back to our formula here, as I already said, the Adams-Bashforth is to continue from where the Runge-Kutta left off. So it has taken the initial values from the Runge-Kutta and then you're going to use a multiple step method to continue, which is the Adams-Bashforth. So I don't want to be talking too much. If you come here to our formula, we want to now start the Adams-Bashforth from y3, right? Now, how do we get y3 from this formula? We can get y3 from this formula by making the I value over here 2. So if I is equal to 2, then we are going to get y3, then here to be y2, here to be f, f2, f1, and then f0. Do you see that? Alright, so again, the other variable here is going to be h. The h we know is 0.2. Then again, we have the f functions over here. Now we're going to get this f defined from the equation we were given, which is y prime equals x. Now, if you make y prime the subject, we said this is the differential equation. So with the single steps, as for the O.D.E, ordinary differential equations, we are solving for differential equations using the single steps. So And then here we are using the multiple step for the Adams-Bashforth. So if you make y prime the subject over here, right? And then if I go ahead find for the iterations, which is for the fi's, you can see they have i's here. For the iterations, I'm going to get xi, yi for whether it is 0, 1, or whatever the I value is. So I'm going to get xi on yi. This is going to be for the iterations. As you go along, you understand this more, right? So this will be for our f, to find for our f values over here, our function values here. And then we know our h, we know. So we can go ahead and start. So as you said, we are starting from y3. Y3 means that the first iteration should have I equals what? I equals 2. So we can find for the first value, which is Y3. So I say we are not starting from Y0. With Adams-Bashforth, we are continuing from what the Runge-Kutta left off, okay? So let's move to the iteration. For the first iteration, we are having I to be equal to 2, okay? I is going to be 2, so we can have Y to be 3. So this is how our formula will look like. We are finding for Y3. We already know for y0, y1, and y2. So for y3, this is our formula here. Now in our formula, we know the value for y2 from the table. We know y2 to be 1.079, but we don't know for f2, f1, and f0. We know h to be 0.2, so we have to find for f2, f1, and f0, right? So we start from f0. This is the formula for f0. If you remember from the iterations, the f iterations here, we said that it's going to be the xi on yi. Now we are starting from x naught. For f naught is going to be x naught y naught. So x naught y naught. X naught here is 0, and then y naught here is also what? 1. So 0 divided by 1, we are going to get 0. So that's for f naught. So x naught y naught. X naught divided by y naught. 0 divided by 1, and then we get 0 for the f naught. So we can go ahead to find for f1. So when the x is 1 and then the y is also 1, we divide them according to the equation. We are dividing it. Then we have, what is x1? X1 is 0.2 divided by y1, which is 1.02. So we divide them and then we have our value for f1. So again, we find for f2, the same to x2 divided by y2. We know x2 to be 0.4 and then y2 to be 1.079. We divide it and we find the value for f2. Okay, so now that we have for f0, y1, f1, and then f2, we can put the values inside this equation over here. We know the value for h and we know the value for y2 from the table to be 1.079, right? So when you put it inside, we can finally compute for this one on our calculator, and we find the value for y3 to be 1.99. We can put the 1.99 where the y3 is. We have found the value for y3. Now we can move on to find the value for y4. Okay, so for y4, we are going to start the iterations from 3. All right, this is the equation. If we want to find the value for y4 here, we have to make the I value 3. So we can have y3 plus 1, which is going to be 4. Okay, so the equation is going to be like this. For y4, we're going to have y3 here, h2, f3, f2, and then f1. So we know the value for y3 from our previous iteration, but we don't know for f3, f2, and f1. So let's find for them. So for f1, we know that x1 divided by y1 is going to be 0.2 divided by 1.02. So we have it over here, these values here. We divide them and then we have 1.923. And again, for f2, we are going to divide 0.4 divided by 1.079. We are going to have the value for f2. And for f3 also, it's going to be x3 divided by y3. We have x3 to be 0.6, and then the y3 was 1.99 from the previous iteration that we just did. Remember that we just found for y3. So you put it inside here and you have your f3 to be 0.3. So now you go back to the equation and then you put the f1, f2, f3 inside this equation, right? And then we know y3 to be 1.99. So if we put everything inside here, we do our computations on a calculator, we will have y1 to be 2.31. So we can put this 2.31 inside our table here, which is going to be 2.31 for the y4. Now the last thing to do is for the last iteration, which is y5. Now again, to find for y5, you have to make the I to be equal to 4. So you can have y4 plus 1, which is going to be 5. Right? So you can find for the last one, which is the y5. So when we do that, and then we say anywhere you see I, you put 4 over there. So here is going to be y4, here is going to be 4, 3, and then here is going to be 2. So now let's find for f4, f3, and then f2. So starting from f2, we are going to say is x2 divided by y2, which is going to be 0.3707. So we have our x2 values and y2 values from the table. 0.4, and then 1.079. Okay, then now you can find for f3. F3 is x3 divided by y3. We know the value for x3 to be 0.6. We know y3 to be 1.99. So when we divide it, we can find the value for f3, right? Then again, we find for y4. Sorry, f4. F4 is going to be x4 divided by y4. We know the value for x4 to be 0.8 from the table. And then from our previous iterations, we had y4 to be 2.31. So when we do our computation, we get 0.346, right? So now that we have f2, f3, and then f4, we can put it inside this equation. We know for h, we know for y4, and then we can find for y5. So when you do that, you put them inside the equation here, and then when you do your computations, you will have y5 to be equal to 3.146. All right, so you can see that we have filled the table. We have found for y3, y4, and then y5, right? So these were the final values, or what we call the loader point for x naught, y naught. So it's better you draw the table and put the values inside like this. So this one is more understandable when you have it in a tabular form like this. You can see that I have represented all these data in a tabular form. So this for the last value, which is 3.146 over here. So this everything represented in a tabular form over here. So again, so the first three y points were computed using the Runge-Kutta fourth order. So this value is 1, 2, 3. These three values I use the Runge-Kutta method. So you can go to my previous video and see how I found this. So we took it from the Runge-Kutta fourth order method, right? And then we continue to find the last three values using the Adams-Bashforth, which is a multiple step method. So the Runge-Kutta method is a single step. Then the Bashforth is a multiple step. So to do the whole thing, we first use a single step method to find the initial values. And then we used a multiple step method, which is the Adams-Bashforth, to find the remaining or the last three y values. All right. So that's what you can find over here. The first three y points were computed using the Runge-Kutta fourth order method, while the last three values were computed using the Adams-Bashforth third order. Thus, the multiple step method, Adams-Bashforth third method, was started with a single step method, which is the Runge-Kutta. So we started the Adams-Bashforth with the Runge-Kutta method. All right. So that's basically the whole idea about the multiple step Adams-Bashforth method. You first start with the Runge-Kutta or a single step method, and then you continue from there. All right, friends. So I hope this is clear. If you have any questions, be sure to give them in the comment section. Don't forget to like and then share with your friends. If you have questions, of course, in the comment section, I'll be willing to reply. And then see you in the next video. Until next time, Apatia.